Okay guys, I forgot to teach you electron dot diagrams on the last video, so let's go for these. These are really super simple. So they're called electron dot diagrams. Sometimes they are called Lewis dot diagrams. And please remember, since they are called dot diagrams, you have to draw dots. Students tend to get these and orbital diagrams, the ones with the arrows that we just did, confused. These are not orbital diagrams. So the electron dot diagrams show you valence electrons around an atom. Valence electrons are the electrons in the outermost energy level of an atom. Valence electrons determine the chemical properties write that down, of an atom. So that's why valence electrons are so important. Your valence electrons are only located in the outer level, s and p orbitals. So if you look at the electron configuration for, where's my periodic table? Let's say gallium. Gallium is, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p1. So valence electrons are in the highest energy level of the atom. If you look here, we have energy levels 1, 2 a couple times, 3 three times, and 4 a couple of times. You have to choose the highest energy level, and that is 4. Be careful because 4 is in 2 places. Now you can count up the valence electrons. There's 2 and 1 equals 3 valence electrons. So even though D here comes in between, should be 1E, it's at a lower energy level. So your valence are only in your highest energy levels, and those will always be S or P sublevels. Valence electrons are shown in the outer energy level of a shell diagram. The shell diagram is this, kind of like the old Bohr model, and it's really an easy way to visualize how electrons are in the electron cloud. It's just a graphic way to look at it. So it shows all the electrons, but we're interested in the electrons in the outermost energy level. So if this has 13 protons, it's aluminum. Aluminum is 1s2, 2s2, 2p6, 3s2, 3p6. Oops, sorry, not 6. 3p1. So if you look here, in our outermost energy level, which is 3, we're going to have 2 and 1, so 3 electrons. And that's what you see here. 1, 2, 3. You have a total of 2, 4, 10, 12, 13 electrons. 2 go here in this first shell. We can have up to 8 in the second shell, so that's a total of 10, and now those last 3 go in the outer shell. So that's how a shell diagram works. We use that too to help us draw our dot diagrams. For a dot diagram, you write the chemical symbol. So the one we were just using was aluminum. We place 1 dot around the chemical symbol for each valence electron, and we can have up to 8 dots. There are 4 sides here to aluminum. So when we look back, we saw that aluminum had its 3 valence electrons. So what we do is we draw them. 1, 2, 3. That's it. They have to be a 1 on each of the 4 sides before they can double up. So we only have 3 sides going, so there's only 1 on each side. It does not matter if you draw it like that down there, or you draw them. It's hard to draw these with my stylus. Let me try this. 1, 2, 3. I don't care which side you draw them on, is my point. Okay, as long as they are singles first and you have the right amount of them. So all inner electrons and nucleus are symbolized by the chemical symbol. So the rest of that picture before that's not valence electrons, that we get from knowing that it's aluminum. All right, let's do a couple of examples. So let's look at lithium here. One easy way to remember how many valence electrons an atom has, besides going through the shell. So if we were doing the shell for lithium, lithium is number 3 on the periodic table. So here's our, not conducive to these dots. So here's our inner electron. Here's the first shell, and the first shell can hold 2 electrons. So we've got 1, 2, and then we draw, oh, it's just not doing well. And then we're drawing, so 1, 2, we're drawing a second shell, since lithium is in the second energy level, and we have 1 more electron to deal with. So that would tell us lithium has, lithium has 1 valence electron. So that's one way to do it. Let's talk about the easy peasy way to do this, and that is to erase this and look at the top of the periodic table. On the periodic table, you have group 1 that has 1 valence electron. You have group 2, it has 2 valence electrons. I don't know why it's erasing. Over here, we don't worry about transition metals because their number of valence electrons can change. We're not worried about the F block. We're going to go over here to group 13. Another name for group 13 is 3A, and it has 3 valence electrons. Group 14 is often known as 4A. It has 4. So I bet you can guess what's happening with the rest. Group 15 has 5. Try this. Group 16 has 6. Group 17 has 7. And group 18 has 8 valence electrons. So that makes our lives real simple. So when we look at lithium, we write down lithium, and it has 1 valence electron. So we do our 1 little dot. This thing really hates dots. All right, so let's look at magnesium. Magnesium's right here. It would have, if we did our, it has, 12 electrons. So we would put 1 here, 1 here. That's 2. So then we would have to draw the next shell. We could do 8 in this, 2, 3, 4, 5, 6, 7, 8. That's a total of 10. We still need 2 more, so I would have to draw a third shell, which makes sense. Its highest energy level is 3, and I would still have to put 2 electrons in that. That would tell me I have 2 valence electrons, so I'll have 2 dots. But again, we can just use our handy-dandy shortcut. So Mg, and it tells us here it's in the second group, so we have 2 dots. And again, it's okay. Oh my goodness. It's okay if your dots are on those sides, it doesn't matter as long as you don't double up until you already have 4. Aluminum. Aluminum over here has 3 valence electrons, so I'm simply going to do this. 1, 2, 3. I know those are small. Oxygen. Oxygen has 6 valence electrons, so we got 1, 2, 3, 4, 5, 6. So we double up after we get those first ones. And then we've got fluorine. And fluorine has 7 valence electrons. So 1, 2, 3. Oops. What rule did I break? I broke the doubling up rule. So sorry. 1, 2, 3, 4, 5, 6, 7. And that's all there is to it, you guys. So I think you'll have a good time doing those. So make sure you get that part of your packet done too, the electron dot diagrams. And I think those are on page, yeah, those are the last page, page 6 in your binder, and also on page 4, part 2. So make sure you get all those done. All right, thanks. Have a great day, guys.